Have you ever wanted to erase an imperfection you believed you had, even if this thing is pretty much impossible to change, to perhaps even a biological level like a trait you got from mum? Well, one of the most amazing revolutions in medicine has currently been founded and has been going well for quite some time. It's a new form of treatment to many hereditary illnesses, showing promise in reversing even the effects in what was once incurable diseases, of which are now successfully being eradicated. It's going to completely change the very fabric of modern medicine as we know it. But it's not that simple. What if this fell into the wrong hands? Well, by the looks of it, it's already being used for alternatives. Influencers are seeking to try it, forever to erase their imperfections, becoming some sort of superhuman, only because they can afford it. But even now, are the consequences of this miracle worth it? For death has already been seen. This treatment is gene therapy, and yes, it is revolutionary, but it's already killing people. So let's go over the research and just see if it's any good. Gene therapy was actually first conceptualized in the 1960s, about 60 years ago, only 10 years after the DNA's double helix was first discovered by Watson, Crick and Franklin. Following this hypothesis, early methods were indeed conducted to see if it was in fact possible. These methods are much different to what we do in the present. For example, scientists at the time tried to inject the genes of living mammalian cells with a micropipette directly into the protein, or expose the cells to a precipitate of DNA that contained the desired genes. However, these methods didn't really work a lot. There was often a low efficacy due to damage to the cells, and the precipitates used often had problems with specificity. However, in 1961, Dr. Lorraine Krauss became the first to successfully perform some sort of gene therapy. She genetically altered the hemoglobin of cells from bone marrow taken from a patient with sickle cell anemia, incubating the cells from the patient in tissue culture with normal hemoglobin DNA. It changed the patient's DNA in the cell, showing that it could in fact be done. 7 years later, more researchers managed to correct cells afflicted with Lesch-Nyhan syndrome, a debilitating neurological disease, by adding foreign DNA. Again, the cells were cured, but not the human. The first actual attempt at gene therapy took place in 1980, but it remains unbeknownst if it actually worked, as the data was never verified. So we continued experimenting on animals throughout the 80s, with the most groundbreaking research taking place in September 1990, seeing as Hanti de Silva successfully being treated using gene therapy for ADA-SCID, a severe combined immunodeficiency disorder. Children with it normally pass away before 5, so at 4 years they tried it as a cure. This is a condition in which the ADA gene on chromosome 20 is basically broken. It doesn't produce adenosine deaminase, which is responsible for making lymphocytes in the immune response. Now, miraculously, Ashanti survived. She's actually still alive today, as far as this research told me. Yet after this, the literature kind of stagnated for a bit. There were a few failures, so science dismissed it. Only following more experimental success in 2006 did it become used again, seen in treating many diseases from myeloma to Parkinson's and even cystic fibrosis. The US actually increased their funding by over $600 million in 2014. In the present, it's only getting more popular. With advanced techniques, as of 2023, the primary methods have evolved to use DNA incorporated into viruses to deliver DNA into a chromosome to express or disrupt a protein. Naked DNA, or unprotected polynucleotides, has also been looked at for vaccines, and it seems to be working quite well in comparison to years ago. Well, in some regards. Let's take a further look at everything gene therapy is getting right. The first main advantage of gene therapy is undoubtedly its efficacy. Whilst it's still not too common, the studies and even instances where it has been used have often worked. Not all the time, but sometimes. Let's look at some of the evidence. Only recently, the NHS in the UK gave a 19-month-old girl called Teddy gene therapy as a potential cure for metachromatic leukodystrophy, or MLD, a fatal genetic disorder caused by a deficiency of lysosomal enzyme aryl sulfatase A due to mutations on the ARSA gene. Eventually, there'll be a toxic buildup of lipids, which are just your fatty acids, and other storage materials in the white matter of the central nervous system. Unfortunately, most children die by the age of 5. Now, before gene therapy, MLD was thought of as untreatable, patients would only receive symptom management and or rare cases bone marrow or stem cell transplants. This only slowed progression though. The gene therapy named Libmeldi inserted copies of working copies of Teddy's faulty genes, restoring her ability to break down sulfatides. She's currently happy and healthy. And that's not all. Another disease thought to be unconquerable was cystic fibrosis. In patients, their CFTR gene has mutated, so it no longer makes a protein crucial in regulating the movement of salt and water in and out of cells, in turn producing a thick and sticky mucus that clogs airways, eventually making it almost impossible for a patient to breathe. With several techniques, science is progressing in its fight. Using viral vector delivery, nasal administration, or even inhalation therapy, these have all shown promise in replacing patients with faulty genes, allowing them to potentially undergo some form of treatment. There's even been links to gene therapy treating cancer. For example, by introducing therapeutic genes into cancer cells, it's thought it will either kill them directly or enhance the body's ability to eliminate them naturally. When someone has cancer, it's often a consequence of a faulty tumour suppressor gene not inhibiting an oncogene. With gene therapy, it's been seen that when these tumour suppressor genes are faulty, the therapy can trigger apoptosis, cell death, reducing cancer. In some cases, it's also thought to replace these faulty genes, potentially reducing the risk of cancer before it actually even begins. But lastly, and potentially the most important difference in my opinion, is that gene therapy has the potential to allow for individualised medicine. We may share 99.9% of our DNA with each other, but that 0.1% makes us unique. If you give everyone who suffers from depression an antidepressant, it only benefits around 40% of patients because we're all still so different, and these differences may well be genetic. With gene therapy, it gives us the potential to aid everyone, allowing for greater treatment and the most efficacious remedies. So, you've got to admit it seems pretty good, doesn't it? Well, yes, but it's not perfect. Here's where gene therapy seems to fail. As said, gene therapy does in fact possess some negatives. For every miracle study such as this one curing people's blindness, we get one like this. This is the longativity gene, or SIRT6. It plays an important role in organising proteins and recruiting enzymes of which repair broken DNA. It's been found in mice that those without the gene age prematurely, and those with extra copies live longer. Naturally, mice have a shorter lifespan and thus fewer SIRT6 copies than, say, a beaver. So when SIRT6 genes of both these animals were taken and placed into fruit flies, the flies with the beaver genes lived much longer. Another study from Harvard simply changed the DNA in mice, which went as far as reversing their aging. I know what you're thinking, this is in mice, so what? Well, I've just the news for you. This is Brian Johnson, the millionaire or maybe billionaire who's just received the first trial of age-editing gene therapy. The genes afflicted by the doctor were the FST genes, of which affect follistatin and concentration, and the gene therapy increases muscle mass and athletic performance. Johnson actually said that his team of doctors have helped him have the skin of a 28-year-old, the heart of a 37-year-old, and the lung capacity of an 18-year-old. If you want to be like Brian Johnson though, it'll set you back $25,000, and this is the issue. Say if this works and rich people do start getting it, reversing their aging, is it ethically fair to let these rich people live forever whilst the poor simply die? Absolutely not. What makes it worse is that the effects of this haven't even been fully studied. These people spending $25,000 on this therapy may end up with too much muscle mass and die within a year. $25,000 just to have a potential heart attack from a different antecedent. We genuinely have no idea what will happen, and this is another massive problem. And deaths due to gene therapy are not unheard of. Since 2020, 4 boys under 5 have died in clinical trials following developing liver dysfunction, and perhaps the most famous case is that of Jesse Gelsinger. He sought treatment for an ornithine transcarbamylase deficiency, a genetic disease afflicting the liver. Jesse had a severe immune response triggered by the viral vector gene therapy used and unfortunately died. This could in fact be what eventually happens to these people getting gene therapy for vanity reasons. We don't know. So there we have it. Gene therapy does seem like a powerful tool, but like anything else, it has its disadvantages, and in this case, the disadvantage is death. Personally, I think the idea of it being used to treat an array of disorders and problems is amazing, but the vanity side is pretty gross. But what do you think? Let me know in the comments below, and if you don't, well, no $25,000 gene therapy for you. Thank you so much for watching. I appreciate every single one of you. Be sure to like and subscribe if you enjoyed. It's free and it really helps me out. See you next time.